All right, so we have our sum and difference identities part 2. Now we're doing it in reverse. So we have sine of 3x, cosine 2x. That's our share. So when you see sine, cosine, cosine, sine. And so you're focusing on the sine. Right here, he goes first, right? And it's the positive that we want. So this would be sine of 3x plus 2x. See it? Sine A, cosine B. So it would be A plus B, A plus B. Adding those gives us 5x. It's a 5. And then with subtraction, it's the same thing, but we subtract. But order really matters here. So you have to really focus on the positive one, our sine, cosine. That's positive. The minus is where it goes. So this is first. So 3x goes first. See, it's the A and the A. So this ends up with being sine x. Cosine's a lot easier. It really is just change the sign. So the two things we're adding is 3x and 2x. But cosine is our control freak, so everything is backwards. So this becomes a minus. So we end up with cosine x. And you're saying, well, what if you put it in backwards? That would have been negative x. Well, let's switch them and see. This would be 2x minus 3x, which is negative x. But if you remember, a cosine is an even function. So this just becomes cosine x. So see, it doesn't matter. You just are subtracting the two angles that are in there, getting an answer. So over here we have a minus, which means we'll do a plus. So all that means is we're adding. So the cosines are actually really nice. And then we now have cosine of 90 degrees. And cosine of 90 would be 0. So the answer is 0. So see, it's just working backwards. Okay. So now let's apply this. So what we have here is our two angles. We have cosine A is equal to negative 5 over 13. And cosine B is 3/5. Cosine A is in quadrant. So A is in quadrant 2. And B is in quadrant 1. So if you remember, each of these is a triangle. So we can write our triangle, but we need to make sure it's in quadrant 2. So that's triangle for A. And cosine is adjacent over hypotenuse. There's our 90. And sine B we'll do in green. And it is in quadrant 1 right here. And the only reason we're doing these is for the signs. So sine is 3 over b, not that sign. The positives and negatives. So we know that everything here is positive, but over here we know that that has to be the negative value and that one is positive value. So if this had been in quadrant 3, both the opposite and the adjacent would have been negative. That's what matters. All right, a little Pythagorean theorem. Negative 5 squared plus b squared equals 13 squared. So b is 12. And that's where that positive and negative comes into. So again, it's quadrant 2, so it's positive 12. And if it had been quadrant 3, it would have been negative 12. All right, now on to our sine. So we have, we'll call it a squared plus 3 squared equals 5 squared. (25 minus 9 is 16. So a equals 4. So now we have all of our different trig values. And what we're going to be doing now is using these to find sine A plus B, cosine A plus B, and tangent A plus B. And this is the hardest part. The rest is just plugging it in the formula. So let's start with sine. Sine of A plus B will be sine A cosine B plus cosine A sine B. Don't need a parenthesis on that one. All right. And then we just come back and plug them in. So sine A would be 12 over 13. Cosine B, that's over here, is 4 over 5. Cosine A, so we're back to here, would be negative 5 over 13, just like we already knew. And then sine of b would be 3 over 5, which we already knew. So you're just using that triangle to find it. And so we can do it for everything. We're going to be doing it for cosine and for tangent. They're all just sitting here. So this would give us 48 over 65 minus, I'm just put the negative there, 15 over 65. And then subtracting those gives us 48 minus 15 is 33 over 65. We still want to reduce these, but 3 and 3 is 10. 3 times 11 is 33. 65 we already knew is 5 and 13. They don't have anything in common. So there you go. There is sine A plus B. So I'm going to modify this a little bit so I have some room for cosine. Okay, so now let's do cosine. So cosine A plus B, again, he's a selfish person. So cosine A, cosine B, minus sine A, sine B. And if we look back over here, cosine A again is negative 5 over 13. And 4/5 for the B. And then sine A is 2/13. 12/13. And then sine B is 3/5, which we already knew. So same thing, this is now negative 20 over 65 plus minus 36 over 65, which gives us negative 56 over 65. And again, we're looking for 5 and 13, neither of which are in 56. So there you go for cosine. Now let's try tangent. Let's do tangent in green. So tangent of A plus B. We haven't done that many tangents yet. In fact, I don't think we've done any. So let's look at our tangent. A plus B is tangent A, tangent B. 1 minus tangent A, tangent B. So it's tan A, tan B, 1, and then you put them together. So it's just them together, added, and then multiplied together. And the way I remember it, if it's plus, it's minus, it's plus. The only one who's straightforward is sine. I always think of tangents as the parent of sine and cosine. So they're the ones who created them both. So if they made a control freak, they got a little control freak in them as well. So plus, minus, minus, plus. In fact, they got a lot of control freak because nobody else is here. It's all tangent. So anyways, back to tangent. Tangent AB, that's just tan A plus tan B. So this is tangent A plus tangent B all over 1 minus tangent A, tangent B. And we just plug them all in. I'm going to zoom in a little bit here and scroll very slowly so don't make you sick. So for tangent, it's going to be 12 over negative 5 for A and 3 over 4 for B. So 12 over negative 5 plus 3 over 4. 1 minus 12 over negative 5, 3 over 4. And so how we simplify these is we use a little LCD. Remember, these are our complex fractions. So we're going to multiply top and bottom each time, because we're going to have a fraction here, by whatever the common denominator is. And it's just the two denominators we have. So if you look at that, that's always the cosines. So we're going to multiply this one by 5 times 4, which is 20. And you can do the negative if you want to, but we're going to keep it simple with just 20. Okay. So this gives us 20 times this would be 4. So 20 divided by 5 is 4. 4 times 12 is 48. And then we need the negative. So this one is negative. 20 divided by 4 is 5 times 3 is 15. 20 times 1 is 20. Minus. And then over here, your 5 and your 4 are going to make 20. That negative is going to turn this into a positive. So that is 20. The 20 will come in, cancel both of them. So 12 times 3 is 36. And another way to do this is to just put a 20 over here for reference, and then you can do a quick little cancel. This would be 4, and so that's negative 48. This would be 5, so that's 15. That would be 20, and then that would cancel completely, giving us positive 36. Now we just have to simplify, and we have our answer. So negative 48 plus 15 is negative 33 over 56. And nothing reduces, so there we go. Now we can check these. All you have to do is plug in your calculator. So we're going to do an inverse cosine of A to get the angle for A, and an inverse sine, an arc sine of B to get our value of B, and then we will just plug them in. So I'm going to do this very quickly in the calculator to show you. So I've done an inverse cosine, inverse sine. So now if I grab them, put a plus, grab it, hit enter, give me my decimal form. If I hit math fraction, still decimal. So the only way to check it is to come back over here and take your 33 over 65 and plug them in. And they should be extremely close. There it is. You see there's a little round off here because there's a round off up here. So there you go. Correct answer. And so you can do the same now for both. You already have the two angles. Just clear these out and then do cosine and then do tangent and check them all to make sure they are correct. We can even use it this way. So if you remember, these are angles. Each of these is an angle. So we're going to call that theta and then omega. And then now we end up with this. This is now sine theta plus omega, which would be sine theta cosine omega, and so on and so on. So we use this for our triangle. So if you remember that that's theta, that means sine theta is 3 over 5, which would give us our triangle. And you got to remember sine. For sine, we're in quadrant 4 and 1, and for cosine we would be in quadrants 1 and 2 for positives and negatives. So this is 3 over 5, so we know that's 4. And since this is also positive, that would now be omega, and so we get 1 over 2. And this one we actually have to do a little, so 1 squared plus b squared equals 2 squared. So minus 1, do it a little bit quicker because we're put a lot of time into this. We get square root of 3. Okay, so now we can just plug them in. And so we know that sine omega would be rad 3 over 2, and cosine omega is 1 over 2. And sine theta is 3 over 5, and cosine theta is 4 over 5. And so just a little plugging in. Sine theta is 3 over 5. Cosine omega is 1/2. Cosine is supposed to be theta omega. There's a typo there. Typos are good because they let us know that we're human and we all make mistakes. As long as we catch them, that means we know what we're doing. So cosine theta is 4/5, and then sine omega is rad 3 over 2. Now with these, we know we're going to use all 4, so just make sure you've plugged them all in and make sure you plug them in correctly. So 3/5, 4/5, yep, and so on. All right, so this becomes 3/10. They both have the same common denominator, 4 rad 3 over 10. So we get 3 plus 4 rad 3 over 10, an exact answer. Now is that easy to check? Yes. We'll pull up our calculator and check it. So I plugged them both into our calculator perfectly, and look, exactly the same. So we know we got it right. Oh, that is our second version now of using sum and difference formulas. Thank you.